All right, so let's tackle this question from IB Physics Paper 2, May of 2025, Time Zone 1. And it's a classic problem from mechanics. So let's dive into the question. A car of mass 1600 kgs accelerates from rest. The graph is given. All right. State what's represented by the area of the graph. Now, IBDP loves to ask this question. They've been repeating this question almost once every 2 to 3 years. So when you have a force versus displacement graph, the area under the graph will always produce the work done by the force. Now, F is the resultant force acting on the car. So the area represented by the graph will be work done by resultant force. Easy. Calculate the final speed of the car. So if you recall from work energy power unit, the work done by an external force on a body equals to the change in kinetic energy. So we're just going to make use of that. Now, for the work done by this force, I need to calculate the area under the graph. So there are two ways to do it. Either you can look at the trapezium, right? Or the other way would be to look at a rectangle and a triangle at the area, and you'll have the work done by the force. Most importantly, students often forget about the multiplier on the y-axis, the 10 to the power 3 multiplier. So do not miss the multipliers. Or instead of multipliers, they would just write it as kilonewtons. That is another way how students often miss out the multiplier. So be aware while you're solving the question, especially during the graph problems. So the area of the under the graph will be, I have this side of the trapezium, which is 60 units. The base is 100 units. And the height is 3000 units. Now, the area under the graph of the area of a trapezium is 1/2 the separation between the parallel sides, so that's 3000, times the sum of parallel sides, so that is 160. This is somewhere like 24 followed by 340, so that's 240 kilojoules. Now, the work doesn't end here. We just have calculated the work done by the force. We need the final speed of the car. Now, if you recall, in the question it was mentioned earlier that the car accelerates from rest. Accelerating from rest implies initial kinetic energy of the car is 0. So we can say 240 kilojoules equals to the change in kinetic energy. Work done by the external force on the body equals to change in kinetic energy. And this is just kinetic energy final minus kinetic energy initial. We also know that this term is 0 because the car is starting from rest. Mass of the car is 1600 kgs, so I can say 240 times 10 to the power 3 equals to 1/2 1600 into velocity of the car squared, and then I just have to solve for v. So I'll just quickly open the calculator. All right, so we are solving for v. Either you could do that, or you can directly move things around and write the final value of v as square root of 240 kilonewtons into 2 over 1600. If you see it that way, that will save you some time. If not, you still have some time to use n solve, and we'll do that. So we move to calc and then solve n. Okay, the equation that we have here is 240 times 10 to the power 3. This equals to 1/2 times 1600 times the variable that we are solving for is v, and v is represented by x over this equation, so x square, and then we are solving for x, and then we close the brackets. More solutions exist. Fine, we get two solutions here. One is negative 13.32 and the other is 13.32. We will disregard the negative value because we just need the final speed of the car. This is 17.3 meters per second. Or since you are reporting the value to two significant figures, you can just say v is equal to 17 meters per second. Better. Let's move ahead. A different car travels on a horizontal road of constant speed 45 meters per second. Engine of the car develops 140 kilowatts power. The resistive force FD is acting on the car, that is given by CB square. V is the speed, C is a constant, determine C. State the fundamental SI unit for your answer. All right. So first things first, we know that the car is moving at a constant speed and the engine develops a power of 140 kilowatts. So when you know that the speed is constant and the drag force is given by this expression, which by the way will also be a constant because speed is constant, V is constant, you can directly write P equals to F times V. Now if I do that, 140 times 10 to the power 3 equals to the drag force into V. What more I can do here is directly substitute FD as CV square. So 140 into 10 to the power 3 equals to C times V square times V. V is 45 meters per second. So I can directly plug in the value of 45 as V in this equation and then solve for C. Time to go back to the calculator once again. So I can do 140 times 10 to the power 3 divided by 45 cube, right? V square into V is V cube. You move it to the other side or you divide the entire equation by V cube. This is what you end up with. And C comes out to be 1.53. Okay, fine. So C equals to 1.5. Two significant figures. The next part is more important. We have to report the answer in fundamental SI unit. Now, here's the catch. A lot of times I've seen students reporting their answer only in SI units. Now, Newtons is the SI unit. That is correct. Joules is also the SI unit for energy. But that's not the fundamental SI unit. Fundamental SI unit will be consisting of only kilograms, meters, seconds, mole, Kelvin, candela, and ampere. These are the 7 fundamental SI units. Everything else that we see is made up of combination of these units. So these are like the base or the fundamental SI units and everything else is built upon this. So our final units, when we are reporting the final answer, the units of C should contain nothing other than kilogram, meter, second, mole, ampere, candela, Kelvin. Nothing other than that. So we need to figure out the fundamental SI unit. Now, in this equation, where I see F equals to CV square, we'll just use this equation for finding out the units to C. I can say that F over V square will be C, which is correct. In order to figure out the units of C, I will start substituting the units of force and speed squared. So force has units of Newton and meters per second squared would be meters per second whole squared. But since we know that Newton is not the fundamental SI unit, we'll replace Newtons with kilograms meters per second squared. Where does that come from? F equals to MA, F equals to M, which is kilograms, and A, which is meters per second squared. Now I just have to simplify this for the units of C. So I have kilograms, meters over meters square will be meter inverse, and then second square inverse will just get eliminated. So my final answer will be C is 1.5 kilograms per meter. That's it. And that's how you solve this question. Marks for free. These kind of questions will fetch you marks very easily. So I hope you guys understood that pretty well. If you've got any doubts, the comment section is always open. Thank you for joining and I'll see you in the next one. Goodbye.